Hi everyone. In this video we are going to discuss about DHCP. So that stands for Dynamic Host Configuration Protocol. So we need this protocol because every node, so that node can be, for example, computer, or maybe this can be a mobile handset, that can be a tablet. So every node on the network, they all need an IP address. There's there is no IP address, it means they cannot create a network and they cannot use the internet, or they cannot use that network resources. So every node needs an IP address, and to give an IP address or to assign an IP address to the nodes, for example, if we have Windows operating system, then Windows operating system, we can go to control panel and the network and internet, and in the network connections we have this window. In that window we can configure the IP address by ourselves. So for example, we can say use the IP address, so we will select this option, and then we can assign some IP address to for this computer manually or statically. So this is how we can focus on 192.168.10.2. In this way, we assign the IP address to the computer manually, and this is known as static way, or statically assigning the IP address to the computers. And the second method is that we can select this option, and this option says that obtain an IP address automatically. So automatically means we don't have to do it by ourselves. There will be some server, or there will be someone on the network that will be assigning the IP address to this computer, and just we have to select these options. Okay, so this is dynamic assignment of the IP address, and for this we use DHCP. So in the case of computer and with Windows operating system, we can assign the IP address in this way. But for example, if we have a networking device, like we have a router here. So in case of router, for example, this is the interface of the router. And we know that these interfaces also needs to have an IP address. And we can statically assign IP address to these interfaces. And the second method is we can configure these interfaces to obtain an IP address automatically. So we can just use this command, that's IP address DHCP. So in this way, these interfaces will automatically receive an IP address using DHCP, which we are going to discuss today. So this DHCP has the DHCP server, and this DHCP or DHCP protocol actually enables these nodes or these interfaces of the router to obtain an IP address from DHCP server. It means there will be some server there, and DHCP protocol actually allows, or this enables these nodes to obtain an IP address from the server. Now this whole process actually can be divided into two steps. So the first step is that the client who needs an IP address, that client has to find out the DHCP server. First they have to find out the server, and then they have to ask for an IP address from that server. And the server, DHCP server, will have a pool of IP addresses, and from that pool, when the DHCP server, so for example in this case, if this DHCP server will request any request for IP address, this server can use this pool of addresses and can assign any one of the IP address to the client. For example, in this case, we can say that this client made a request, and DHCP server on the basis of request has assigned this IP address to this client. And this IP address will be assigned for certain time, that is known as lease time. And the lease of IP address can be reclaimed by the server once the lease expires. So it means that IP address has been given to the client for certain time, and when the certain time expires, that IP address can be taken back from the client. And we can also renew this lease to the client. So client can request for extension in the lease time as well. Now DHCP uses the following 4 messages to receive an IP address. So in this case, this actually works in the client server way, or the client server model. So the client who's requesting for the IP address is client, and the one who's offering the services or giving the IP address, that is the server. So in this case, for example, this can be client, any one of them can be client, and this is the server. Now these four messages are following. The first message is discover message, and in this discover message, the client actually broadcast the message, that is DHCP discover message, to find out the DHCP server if this is available on the network. Second message is, once the server has received the message, server will send an offer message. Then that offer will be about IP address, so that offer message will be sent back to the clients. And then the client, after receiving that offer, the client will send a request to the server for the IP address. So it has to request again. It has to request back to the server that yes, I accept your offer. And finally is acknowledgement. So once the server has received that request from the client, the server will send an acknowledgement message, and this acknowledgement message, the server will agree that yes, you client, you can use this particular IP address, and then this process will stop and client will have an IP address assigned. Now let's just discuss in details about these four messages. And yes, to remember these four messages, we have this word, that is DORA. So D, discover, O, offer, R, request, A, acknowledgement. So this is a DORA process, or the DORA word, which actually comprises of all these four messages. Now the first message in this DORA is discover, and this discover message, actually what happens, the client, for example, this is the client which needs an IP address. So this client has to send a discover message, and now this discover message will have the header. So in the header part, so this information has to travel in the IP packet. So in the header part, we need an IP address for the destination as well as for the host. But at this point, the problem is that this client does not have an IP address. Actually, this is looking for the IP address. Then how can we assign a source IP address to that? And it also doesn't know the destination server's IP address. So actually, in this case, the client uses source IP address. So this source IP address 000, the client will use this IP address as a source IP address, the first one, and in the destination it will use 255, 255, and 255. So this is basically a broadcast address. It means this user, any of the user who's requesting for the IP address, in the source, as per protocol, as per rule, they will use 0.0.0, and for the destination they will use this broadcast message. Now this is broadcast, means this will be received by all the nodes on this network. So it means all the nodes, means this one also receive, this will also receive, and DHCP server will also receive that message. So all the nodes will receive that message, but only DHCP server will respond, because this is the request for the DHCP server, but not for anyone else. So these all remaining nodes will not process it, or they will reject it, but only DHCP server will process it and will respond to it. Now once DHCP server has received a request for the IP address, then this DHCP server can send an offer message back to the client. So it sends a lease offer for an IP address is sent by the DHCP server. So DHCP server sends a lease offer to the client, and this case where this message will be sent. So again, let's see that yes, this will be sent in a packet, and now in the header part we need the source and destination IP address. So for the source, now the DHCP server itself is the source, so the first part, so that is the DHCP server address, but in the destination is still this client does not have any IP address. So in the destination IP address, again the server will use the broadcast address. It means this offer message will be sent to not only the requesting client, but all other nodes which are available on the network, they all will receive this offer message, but only this client will accept it, others will reject it, because in the payload there will be some information about the client. So that is actually client hardware address. Because of that, only this client will receive, everyone will receive, but this will further process it. So this will be in the broadcast message, and everyone will ignore it except the client who sent the discovered message. So only the client, they will further process it. And this is because of the client ID, that is client hardware address, that was sent by this client in the payload part of this one. So when it was making the request, it somehow included its identification in the payload. So when it is going to receive back the offer message, other nodes will not process it. Only the intended or the required client will process it. So that's because of this client hardware address, which is in the payload part of this one. Okay, so now when this user, for example, this client has received an offer message, now this client, they have to send a request message back to the server. So in this way, they have to send a request message to accept the offer. So sent by the DHCP client to ask the server to lease out IP address. So once they has forward the offer message, they will send a request message that please assign this IP address to me, which you sent in your offer. Now in this request message, again, we have to send an IP packet. So in that case, we need a source IP address and the destination IP address. And look, this is the important point. Is still this client does not have any IP address of its own. So it has not been assigned. Yes, it has received the offer, but it has not accepted it. Still, we need a message. So again, in the source IP address, this client will still use 0.0.0 and 0, and the destination, it will again use the broadcast message. It means for this request message as well, this message will be sent to all the computers available on the networks, including DHCP server, because of this broadcast IP address in the destination. And then when the DHCP server has received the request message by the client, now it will send an acknowledgement message, and this acknowledgement message will permit, or now this acknowledgement message will allow, or this will assign that IP address to this client. And now for that, what happens, this acknowledgement message has to be sent, and for that, now this time the DHCP server use its own IP address in the source IP address part, and the destination, this will use again 255.255 or this broadcast address, because still the client does not have an IP address. So now this acknowledgement message will also be sent to all the nodes, but the rest of the nodes will just reject it, and only this client will accept it and process it. In this way, this client will have an IP address. And so now this computer will have an IP address, and only this will process because of, again, this client hardware address included in the message. So once these four messages has been sent or exchanged between the client and the server, the client will have an IP address, and the client can use the networking resources or can use the internet. So this DHCP server has a pool, as we discussed. So in addition to the IP address, this DHCP server actually can be configured to offer other network configuration information as well. So for example, these client machines, they also need the address of the default gateway. So default gateway, it means if the computer wants to send some data to some other network, which are to the nodes which is not on the local area network, then it needs a gateway, a default router. So that information can also be sent by this DHCP server. And of course, this, in addition to IP address, is also assigned the subnet mask, and it also gives the lease time in that message and it can also send the information about DNS server. Now, for example, in Windows machine, I have selected this option that obtain an IP address automatically. It means obtain IP address from DHCP server. So in this case, if we have the DHCP server and our computer might have been assigned an IP address by DHCP server, so we can check this one. So for example, we received an IP address by this configuration. We can check whether we have an IP address or not. So for that we can use this command, that is ipconfig /all. So with this command we will have this information. For example, in my case, you can see I received an IPv4 address. You can see this is the IPv4 address, and then we have this lease, that this is the lease, and then this is the time when lease expires for this IP address. It means this will be the time then lease will expire. Then I also got the information about default gateway, DHCP server. So I have got these all information from a DHCP server. And yes, so I hope this was a bit useful, and let's do the same thing in Cisco packet tracer.